Top 6 types of aluminum finishes. The natural surface quality and finish of aluminum means it can be used for a variety of applications without any surface finishing required. However, there are instances when a range of aluminum finishes are needed for different reasons, such as aesthetic improvement, better surface structure, increased resistance to corrosion, and enhanced electrical insulation. The following are the top types of aluminum finishes with different properties and their suitable applications. Anodizing. This is an electrochemical process that offers adequate protection by creating an oxide layer on the surface. Since it minimizes wear on aluminum parts, it provides improved adhesion for glues, paints, and primers. The process is done by immersing aluminum in an electrolytic bath. As the current flows, an oxidation reaction occurs, creating a thick layer of oxide. The resulting oxide layer is durable, provides excellent abrasion resistance and corrosion resistance. These are some of the benefits of anodizing aluminum. Improved aesthetics. Maintains the appearance of the product. Creates functional specific surfaces. Better electrical properties. Smooth and uniform surfaces. It is possible to achieve varying thicknesses of aluminum oxide to get the desired benefits. For instance, if you want to achieve a better finish and improved corrosion resistance, you should go for a thicker anodic layer. Powder coating. The powder coating technique coats metal parts or objects with the protective layer that is resistant to wear. This method is commonly applied for aluminum due to its numerous advantages, such as improved durability, abrasion resistance, corrosion resistance, and better aesthetic appeal. Powder coating materials are available in two forms. Thermoplastics. They are high-performance coating materials that provide a range of physical and chemical properties, such as impact resistance, durability, color stability, flexibility, and gloss retention. Thermosets. They are polyurethane or epoxy-based powders. These are more versatile than thermoplastics and have varying levels of reactivity. The aluminum powder coat can last for years with minimal maintenance. In addition, powder coating offers aluminum a smoother finish than conventional paint. It is also possible to have a powder coat with a range of finishes and colors. Anodizing or passivation. Anodizing, also known as chem film, is a coating that protects aluminum from corrosion. The surface of aluminum is covered by a coating through chemical processes. In this case, chromium salts and chromium acid react with aqueous solutions to create a durable adhesive coat. This results in the addition of a protective layer to aluminum through a process called passivation. Anodizing aluminum can be used in a variety of industries such as military, aerospace, precision machining, and electrical industries. Unfortunately, the aluminum finish created has minimal abrasion resistance. Therefore, anodized aluminum parts do not have a great decorative finish. Liquid paint. Liquid painting is quite common because it is easier as compared to other methods and provides a variety of composition variants and colors. Although this surface finishing technique has many advantages, it has its share of limitations. Liquid paint is known to produce more waste as compared to powder coating. Also, it is difficult to attain consistent color with this process. Liquid coatings contain volatile organic compounds, VOCs, which pose serious health concerns. The main advantage of liquid painting is its variety of paint types. For instance, it is possible to paint polyester, silicone, acrylics, and PAV. This method is also easily accessible and can be a perfect choice for the right projects. Mechanical finish. It is possible to attain a range of aluminum finishes through mechanical processes. This is because aluminum can be blasted, sanded, ground, polished, or buffed. Grinding is known to produce a surface that is blemish-free and extremely flat. In this case, with the help of a rotating abrasive wheel, the anomalous surface material is removed. The major problem with this finishing process is that grinding machinery easily gets clogged. Also, if not done properly, it can result in overheating the surface. Buffing is quite similar to polishing, but it is mainly used to get rid of emery marks. The only difference is that it uses less abrasive grains as compared to polishing. Blasting is another mechanical finishing process. It is commonly used to remove surface debris to achieve finite shaping. The process involves using a pressurized fluid with different materials such as baking soda, sand, metal shot, and glass beads to blast the aluminum surface. The polishing process uses a profile polishing tool to create a reflective surface. A soft cloth wipes the surface of the metal to reveal the shine. Tumbling provides an action that is similar to rocks tumbling down a hill. Aluminum parts are placed in a barrel that contains compounding agent, abrasive media, and water. The rotation motion produces friction that abrades the parts. This mass finishing method is suitable for manufacturers that want consistent results without the need of automated machinery. Vibratory finishing involves placing of media, compounds, and parts in a vibratory bowl or tub. Vibration creates a force that causes parts and media to turn and grind against themselves, polishing or deburring. This is another mass finishing method that is used for finishing applications, such as surface preparation and cleaning. Depending on functional or aesthetic requirements, manufacturers can opt for dry par, wet vibratory finishing, coating. E-coating, also known as electrostatic coating, uses charged paint particles to coat aluminum parts. With the help of electrostatic technology, the paint adheres to the surface to create a thin coating of paint. This method is quite popular because of its cost-effectiveness and efficiency. There are two main types of e-coat: anodic e-coating and cathodic e-coating. E-coat paint has excellent durability as it adheres to the surface well and does not come off under normal conditions. The coating also provides improved resistance against corrosion. With this finishing method, it is possible to achieve uniform film thickness. The coating thickness is determined by the amount of voltage supplied. Conclusion: the choice of aluminum finishing method comes down to machinery availability, budget, environmental requirements, safety measures, and the need for skilled manpower. You should note that different aluminum finishes can improve the aesthetic appearance of your parts. Therefore, there is a need to choose the right type of finish that suits your application.